Hello everyone, welcome back to Diksha Karnataka YouTube channel, and in the second PU midterm revision series I am going to discuss all the important questions from the chapter alternating current. I have already did a theory revision of the chapter, all the formulas, all the equations, all the concepts I have discussed in that small 35 minutes 40 minutes video. So you can go and check that out. But before before you go, I request you to watch this video first. Also, if you have not yet subscribed to our channel, definitely subscribe to our channel. Your subscription matters to us, and obviously share this video with your friends so that our channel can grow very quickly. Without much delay, let me continue with the chapter. So first we are going to discuss 15 MCQs, most probable MCQs. Then we will also discuss 5 fill in the blanks question, and lastly we are going to discuss 5 numerical questions which are very important and standard numericals, particularly for this chapter. And if you are someone who is very afraid of solving numerical questions, definitely this is one of the easiest chapter in terms of numericals. Few formulas you have to remember, and how you can apply those formulas to solve questions, that you have to understand. Then you can solve the questions, at least the numerical from this chapter you can answer it perfectly. No much difficult mathematics is not there. Okay, so don't go anywhere, watch till the end, and obviously I hope that after this video is over, you should be able to solve at least one numerical in your midterm exam. Now let's start with the MCQs. An ideal step-up transformer decreases current. Step-up transformer increases voltage, so that means current has to be decreased, so it decreases the current. Next question, in a transformer, NP and NS are the number of turns present in the primary and secondary coils respectively. The transformer is said to be a step-up transformer. So we know that Vs by Vp equals to NS by NP. Now if it is a step-up transformer, for a step-up transformer, step-up means it is increasing the voltage. So step-up transformer means the value of Vs must be greater than that of value of Vp. Vp is primary, Vs is secondary, right? So in case of a step-up transformer, the value of secondary voltage must be higher than that of the primary voltage. So Vs must be greater than Vp. So from there we can say Vs by Vp must be greater than 1, or Ns by Np must be greater than 1, or Ns must be greater than Np. So the number of turns in the secondary must be higher, so Ns must be greater than Np, so Np must be smaller than Ns. So this is how you can identify it. So correct answer is option A. Next, in a transformer, the windings of the primary and secondary coils are wounded one over other to reduce the energy loss due to. So here you can see that there are few energy losses in a transformer. So one over another. So this is how you reduce the flux leakage. Okay, the flux which is coming out of the primary linked to the secondary. Now if you wind one over another, then the flux leakage becomes minimum. So flux leakage is the energy loss that you try to prevent. So as you can see, most of the MCQs from this chapter are based on transformer. So transformer is, even though very low priority, from this chapter you can expect some of the questions based on transformer as a MCQ question. In case of alternating voltage applied to a resistor, the current leads the voltage by a phase angle pi by 2. The current lags behind the voltage by an angle of pi by 2. The current and the voltage are in same phase. So basically, in case of a resistor, V is equal to Vm sin omega t, and I equals to Im sin omega t. Both are omega t. There is no phase difference. Phase difference between these two is 0. So phase difference is 0. So difference 0 means they are called in phase. If phase difference is 0, then it is called they are in phase. Okay, so they are in phase. Next question. The average power dissipated in an AC circuit is maximum if the source AC is connected to a pure resistor. Okay, if it is connected to a pure resistor, then the power dissipated will always be maximum. So this is the case. Otherwise, in resonance also power can be maximum, but resonance is you have to do some mathematics, do some calculation. But if you are always connected to the pure resistor, then it will always be greater. Next question. Next, before I continue, I will like to introduce you to the new offering by us, KC90, which is a completely offline course for all the students who are appearing for KCET 2026 as well as Comet K 2026 exam. Those who are preparing for these two exams, they are very essential for you to prepare them very hard and prepare them well. Okay, the exam is not simple as many students think. So if you want to prepare through the most experienced faculties of Diksha colleges, then definitely you have to call this number. The number is given in on your screen, also given in the description of this video. You can call this number and definitely book your seat today. The seats are limited. Okay, class obviously will start in a few days of time, but you have to book your seat right now. The link is given in the description, as well as you can call on this number and book your seat today. So let's continue with our MCQ. The power factor for a pure capacitive or pure inductive circuit is 0. Power factor for pure capacitive, pure inductive, no power is consumed, so power factor is 0. The resonance phenomenon is exhibited by circuit only if following components are present. So resonance phenomena, to observe resonance, you have to have an inductor and a capacitor. That is mandatory, right? Resistance is optional, but XL must be equals to XC. That means XL and XC both has to be present. If one is missing, then you will not observe resonance. So both L and C is required. Okay, resistance is not compulsory, but L and C is compulsory. So this is how you can observe resonance. The relation between peak value Im of current and RMS current is. So what is the relationship between peak current and RMS current? We know that RMS current is equal to peak current divided by √2. So this is the relation here. Now the same question can come with using voltage as well. The relationship between peak value of voltage and RMS value, it is given by this equation. Okay, so you have to remember that RMS equals to peak value divided by √2 always. The relationship between peak value Im of current and RMS current is given by, I think this is the same thing. Yes, same value. Somehow the question gets repeated. The output voltage to a pure inductor is V is equal to Vm sin omega t. Then the current in the circuit is, so pure inductor, in case of inductor the current lags, so current will be lagging behind the voltage, so it will be I is equal to Im sin omega t minus pi by 2. So this is the answer. Okay, in pure inductor current lags behind, so that's why there will be negative. Okay, in pure capacitor current leads, so that will be positive. The input voltage to a pure capacitor, again this is related to capacitor, V is equal to Vm sin omega t. Then the current in the circuit is, the current in the circuit is sin omega t plus pi by 2, not cos but sin omega t plus pi by 2. So correct answer is this. Next, in a series LCR circuit, L and C are interchanged, the resonance frequency of the circuit. So it's a series combination, so it does not matter even if you interchange L and C, if you interchange the position of L or C, it does not matter as long as they are connected in series. So the resonance frequency will remain the same, it does not change if you interchange the L and C. The power factor of an AC circuit is 1. Then the phase angle between the voltage and the current is. So power factor is 1 means cos phi equals to 1. Now if cos phi equals to 1 means phi must be equals to 0. Right? Cos 0 is 1. So the phase angle must be 0 degree. which of the following is not a reason for energy loss in a transformer? So in a transformer there are few types of heat loss, flux leakage, eddy current, heating effect, they are all actual causes of heat loss. Electrochemical effect definitely has no relationship with heat loss in a transformer, so electrochemical effect is a wrong answer. What type of material should be used as a core to reduce hysteresis loss in a transformer? Now this is something, hysteresis used to be part of the syllabus, but only it is left as a loss in a transformer. So hysteresis loss, to reduce hysteresis loss we use soft iron as the core of a transformer. So material with low hysteresis loss is basically used, which is soft iron. Okay, so soft iron is used. Now fill in the blanks question. The principle of working of a transformer is mutual induction. Mutual induction is the principle of working principle of a transformer. The power factor of AC circuit containing pure resistor is 1. So power factor of AC circuit with pure resistor is 1. Or you can say maximum. If you see the maximum is not there, 1 is there, so 1 can also be answer. Anyway, maximum can also be answer. A rotating vector used to represent alternating quantities is called phasor. Okay, now if you have any doubt in such cases, you check all the options. If one is more appropriate or more suitable in some answer, then you have to mark 1, otherwise maximum can also be the option. Okay, the average power dissipated in an AC circuit is dash if AC source is connected to a pure capacitor. So if it is connected to a pure capacitor, the energy consumed by it is 0, so power consumed is 0. The current through an ideal inductor is called wattless current. The current through an ideal inductor is called wattless current. Okay, now so in this case maximum and 1 both are possible. Somehow that is missed, so it can be power factor in a pure AC circuit can be 1 as well. Okay, maximum, it can be maximum, it can be 1, both are correct. So in that case both options should have been given as full marks, right? Now let's solve some numerical questions from this chapter. We will be solving 5 numerical questions. So let's start. A series LCR circuit contains a pure inductor of inductance 5 Henry. So inductance means what? So L is given as 5 Henry. Okay. Capacitor of capacitance 20 microfarad. So C is 20 microfarad. Now microfarad to farad you have to convert. Okay, microfarad is not SI unit, so you have to convert it into farad. Farad means, micro means 10 to the power of minus 6. The resistance is 40 ohm. Okay, if the AC source is of 200 volt and 50 hertz. 50 hertz is the frequency. Okay, as I said, in case of numerical questions, it will always give in terms of frequency. So 50 hertz is the frequency of the applied AC source. Find the impedance, also find the resonant frequency of the circuit. So both you have to do, resonant frequency as well as the impedance. First we will calculate the impedance in this given case. So calculate impedance, what you have to do, you have to calculate XL, and XL is equals to omega L or equals to 2 pi F into L. Okay, so what is 2 pi F? 2 pi into F is 50 hertz and L is given by 5. Okay, so it will be pi to 100 into 5, 500 pi. 500 pi is XL. Okay, what is XC? XC will be 1 by omega C or 1 by 2 pi FC. So if you are very comfortable using calculator, then this kind of questions are very easy, because yes, as you can see, the values are not very good, because it's not a competitive exam. In competitive exam, if you are solving the questions, then in that case you get the values, the frequency is given such a way, the pi gets cancelled, but it is not a competitive exam, so you will not get that opportunity over here. 2 pi into 50 into C is 20 into 10 to the power of minus 6. But you have a calculator, the basic calculator is allowed, where you get the value of pi as well, 3.14, which will be about approximately 1500, okay, ohm, okay, approximately. Anyway, I am not solving that problem exactly, so you can use your calculator and find the exact value. Here it will be 100 into 20, that is 2000 pi. Okay, so 2000 pi means it will be 1000 by 2 pi, or it will be 500 divided by pi. Okay, which will be approximately some 200, not 200, 150, approximately 150 ohm. Okay, 500 divided by 3.14, you will get about 150 ohm. Okay, exact value I am not calculating, you can use the calculator to calculate the exact value, but I am showing you how to solve this question. So what is the impedance? Then impedance will be square root of R square plus XL minus XC whole square, that is R is given by 40, so 40 square plus 1500 minus 150 whole square. Okay, you can calculate the impedance again using a calculator. You can calculate the impedance, not much difficulty. Now resonance frequency, how to calculate resonance frequency? Now resonance frequency is a particular frequency which is given by f naught equals to 1 by 2 pi square root of L into C. Okay, so this is the formula for resonant frequency. If you use this formula directly, you can answer it. So 1 by 2 pi, L was 5 Henry and C was 20 into 10 to the power of minus 6. So 5 into 20 into 10 to the power of minus 6. Okay, carefully if you solve, you can answer this question as well. Okay, so it will be 100 into 10 to the power of minus 6, so 10 to the power of minus 4 square root, so it will be 1 by 2 pi into 10 to the power of minus 2, or it will be 100 divided by 2 pi, or 50 by pi. Okay, so the correct answer will be in this case, so this will be 1412 ohm. Okay, and this will be approximately 16 hertz. Okay, so this is how you can solve this question. As you can see, mathematics is not difficult. Formula, just calculate it, put into the formula and you can solve it. This is a very common type of question from this chapter. Only thing is that you have to use a calculator. Without using calculator, exact solution is not possible. Okay, pi value you know, if you don't know 3.14, you can use it, the approximated value of pi. Okay, so that value you can use it and you can calculate all the solution, all the questions. Next, an AC source of frequency 50 Hz is connected in series with an inductor of 1 Henry, a capacitor of 90 microfarad and a resistance of 100 ohm. The current leads or lags the voltage. Calculate the phase difference between current and the voltage. So first of all, we have to see whether who is bigger, XL is bigger or XC is bigger. Okay, so this is also a type of question. We know that in case of inductive circuit, the current lags behind. In case of capacitive circuit, the current leads. In case of pure resistive, both are same. So resistance does not play any role. Only role that plays is by the inductance and the capacitance. So we have to calculate the both reactances. First we will calculate XL. XL is equals to omega L. Okay, so that is 2 pi F into L. Let's put the value. 2 pi, frequency is 50 Hz and the inductance is 1 Henry. So let's put that. So you get 100 pi or 314 ohm. Okay, so 314 ohm is the XL inductive reactance. Now we have to find the capacitive reactance XC, which is given by 1 by 2 pi FC. So 1 by 2 pi into 50, and the capacitance is given by 90 microfarad. 90 microfarad, 90 into 10 to the power of minus 6. So now put that value and you can calculate. 10 to the power of 6 goes up, and in the division you get 100 pi into 90. So 90 into 100, 9000 pi. So it will be 10 to the power of 3, that is 1000, divided by 9 pi. So you can calculate this approximately 100 by pi. 100 by pi means approximately 35. So as you can see in this case is that XC is smaller than XL. So XL is bigger than XC. That means the circuit is a inductive circuit. That means in case of inductive circuit, current lags behind the voltage. This is a small concept, that if circuit is inductive, that means after calculating XL and XC, if you see that the XL value is greater than XC, then current will lag. If XC value is greater than XL, then current will lead. Okay, now what is phase difference? Phase difference is given by tan inverse XL minus XC divided by R. Put that value and you can calculate the angle. So it will be about 70 degrees. Okay, if you put these values, 314 minus 35 divided by the resistance, which is 100. Okay, if you calculate that, you will get this to be tan inverse 2.79, about 70 degrees. Okay, now in case of exam, you are not allowed to use scientific calculators. So tan inverse, you will not be able to calculate the exact value of tan inverse. So you can leave your answer like this, which is completely acceptable. Okay, because it's a not standard value. So in case of non-standard value, you can leave the answer as it is. That will be considered and you will get the full marks. Okay, don't worry about it. Now next question. A sinusoidal voltage of RMS value 200 volt and frequency 50 Hz is applied to a series RC circuit. So only RC is there, okay, L is not there, in which R is 3 ohm and C is 800 microfarad. Calculate the impedance and the current through the circuit, phase difference between current and the voltage. So another easy question. So first, obviously we know that Z equals to, normally what we know is that Z equals to R square plus XL minus XC whole square, right? This is the formula for impedance. Now here no L is involved, so no L involved means XL will be 0. So impedance is nothing but simply R square plus XC square. Okay, so if you just put XL equals to 0, you will get the impedance in this case. So you have to just simply calculate XC. So what is XC? C equals to 800 microfarad. So XC will be equals to 1 by 2 pi FC. Put that value. So XC equals to 1 by 2 pi into frequency is 50. Frequency generally is 50. That's what we use in our home as well. So frequency, the capacitance is 800 microfarad. Micro means 10 to the power of minus 6. So it will be 10 to the power of 6 up, 800 into 100 pi. So 1, 2, 3, 4 zeros will cancel. So you will get 100 divided by pi. Okay, 100 divided by pi. 8 pi, sorry, 100 divided by 8 pi, which will be approximately 32 by 8. 32 by 8 means 4, approximately 4 ohm. Okay, so Xc will be approximately 4 ohm. Now put that value, so calculate Z. So resistance is given here 3 ohm. So 3 square plus 4 square, which will be 9 plus 16, which is square root of 25, that is 5 ohm. So 5 ohm is the impedance of the circuit, right? 5 ohm. Next is the current through the circuit. So how to calculate the current? Current is simple. Current is given by current, generally AC we generally show it using small I. So the voltage is 200 volt divided by the impedance. Okay, so 200 volt divided by 5 will be 40 ampere is the current. Next is the phase difference between the current and the voltage. Phase difference is simple, tan inverse. Now XL minus XC by R. Okay, XL is 0, so you will put XC by R. Okay, XL is 0, so simple XC by R is sufficient, which is tan inverse 4 by 3. Now this is a standard semi-standard angle. Semi-standard angle, it is 53 degrees. Okay, so you can leave the answer over here if you are confused, but tan inverse 4 by 3 is a semi-standard angle, 4, 3 and 5, that gives you a perfect right angle triangle. Okay, and angles of 37 degrees and 53 degrees, those who are doing competitive exams, they are aware. I have also covered it in my basic physics video, bridge course video. So you will get 5 ohm as the impedance, 40 ampere as the current, and 53 degree as the phase angle. Not difficult, as you can see, even though the question looks very long and difficult, but actually it is not super difficult. You can solve them one by one. Now next question. A resistor of 50 ohm and pure inductor of 250 millihenry and a capacitor are in series circuit containing an AC source of 220 volt 50 hertz. In the circuit, the current leads the voltage by 60 degrees. Find the capacitance of the capacitor. So here nothing is given, only it given that the current leads the voltage by 60 degree. Current leads, that means phi is basically XC must be greater than XL. Okay, if current leads, then XC must be greater than XL. Now what is the formula for phase difference? Phase difference is tan inverse XC minus XL. Why XC minus XL? Because current is leading. If current lags, then XL minus XC. If current leads, it will be XC minus XL. You have to remember bigger minus smaller, always. Bigger value minus smaller value. Now if based on the question, you can adjust it. Okay. Now this angle is given as 60 degrees. So tan 60 equals to XC minus XL by R. Now what is the value of tan 60? Tan 60 is root 3. So basically it is equals to root 3. Right. Now R is given as 50 ohm. So XC minus XL equals to 50 root 3. 50 root 3. Now you have to calculate XL and put it into this equation. What is XL? XL is simple, it is 2 pi f into L. So 2 pi, frequency is 50 hertz, and inductor is given here as 250 millihenry. 250 millihenry. Milli means 10 to the power of minus 3, and reactance is always ohm. So 100 into 250 pi into 10 to the power of minus 3, or it will be 25 pi ohm. 25 pi is the XL. Now put that value, so you get XC equals to 50 root 3 plus XL, which is 50 root 3 plus 25 pi. Okay, now you have to put these values again. As I said, the questions are easy, formulas are limited, but you need a calculator to solve the exact value. That is the major thing. Now put the value of XC. XC is 1 by 2 pi F into C. That is equals to 50 root 3 plus 25 pi. Okay, this much calculation you have to do. From there you can calculate C equals to 1 by 2 pi into F is 50. This much is common. 2 pi F is common. C you have taken here, and this will come as a division. So 50 root 3 plus 25 pi. Okay, you can simplify this to calculate the capacitance of the circuit, which will come out to be approximately 20 microfarad. Okay, microfarad means there will be 10 to the power of minus 6, which will come if you calculate it properly, and 20 microfarad will be the answer. Okay, now next question, last question of the day. A sinusoidal voltage of peak value 220 volt is applied to a resistor, to a series LCR circuit which has a resistor of resistance 5 ohm, a pure inductor of inductance 32 millihenry, and a capacitor of capacitance 800 microfarad are connected. Find the resonant frequency. Calculate the impedance and power dissipated in resonance. Very interesting. So here in this case the frequency of the source is not important. They directly ask you to calculate the resonant frequency. So resonant frequency is given by 1 by 2 pi square root of L into C. So we will put that value 1 by 2 pi L value is given as 32 millihenry. So 32 into 10 to the power of minus 3, and the capacitance is 800 microfarad, means 10 to the power of minus 6. Now simplify this, it will be 1 by, so 64 into 2, that is 32 into 8. 32 into 8 is 64 into 4. 64 into 4. So 4 in. So let me do this. 32 is 8 into 4. So it will be 8 into 2. Okay. So square root of 32 into 8. 32 means what? 32 means 8 into 4 into 8. Okay, so square root of that will be basically this 2 multiplied, so 8 will be coming out, and square root of 4 is 2, so 16. Okay, so this 16 is coming out of the square root. Now if you check the whatever is left inside, it will be 10 to the power of minus 9 plus 2, minus 9 plus 2, 10 to the power of minus 7. Okay, so this will be the resonance frequency. So it will go up and it will become 10 to the power of 3.5 divided by, so it is slightly tricky, worry not, you can have it like this as well. 16 to the 32 pi into square root of root 10. So this is how you can simplify it. Okay, you can put your calculator and you can calculate it, which is easily calculatable, right? So the resonant frequency value will come out to be 10 hertz. So this will come out to be 10 hertz. You can check if it is coming out to be 10 hertz or not. Okay, now what next is calculate the impedance and power dissipated at resonance. Okay, so impedance at resonance is, you don't need to calculate anything. Impedance at resonance basically is equals to the resistance of the circuit. Okay, impedance at resonance is equals to the resistance of the circuit. Okay, because XL is equals to XC, so XL and XC they cancel each other. So at resonance it is nothing but 5 ohm. Okay, so at impedance at resonance is equals to 5 ohm, and the power dissipated is also very easy. Okay, Power dissipated is also very easy, simple formula. The old Ohm's law formula you can use. Power is basically V square by R. Okay, V is given over here 220 volt. So 220 square divided by 5. Okay, which will come out to be 4840. 4840 watt. Okay, so power is calculated, resistance is calculated. Only thing that you have to take some time is to calculate this resonance frequency. Okay, step by step, but everything, as you have seen, that it is a methodical questions. All the questions are methodical based on certain formulas and equations. So if you practice it little bit more, you can solve all the questions, and it is easily solvable using your calculator. I wish you all the best for this chapter and your upcoming midterm exam. I'll be back with one more chapter very soon. Ray optics chapter we will discuss next. That will be the last chapter for your midterm preparation, and let me know in the comment below how is your midterm preparation is going on. It is coming to your door every day, so prepare hard and please wait for my next video. Till then, bye.